A very warm welcome to all. This is Institute of Global Professionals free webinar. I am your host for the evening, Lursha L. Pelaez from New Era University, Quezon City, Philippines, saying, let us all have a meaningful evening as IGP provides new learning. We are hoping that all of you will be associated with IGP as a global member. Just continue being with us in all the webinars. Check in on the IGP page, recommend IGP, and mention your friends. Each time, you can also like and comment in our webinar. Don't forget to tag and share with your friends and community. We believe that power is gained by sharing knowledge while embracing the chances of this learning. Before we start our program, let us learn more about IGP. IGP is an institution of global professionals which serves student and community resource. We provide holistic social work and education to create a proficient generation. Our mission is to empower people and enhance effective training and consultation all over the world. We organize our webinar, training, offline and online courses by best and trained speakers, coaches to create a best learning platform for all of you. We have already completed 114th webinars successfully. We expect that all the webinars help you in your professional growth, and we wish that you will stay with us in this long journey. Let me remind you again to share, tag, and comment because your encouragement helps us to do better and provide quality service to all of you. And for the certificate, please click the link www.eduigp.com, click Enroll now, and after the webinar, you can claim your e-certificate. No need for the class code, just click the Claim Your Certificate. Without further ado, ladies and gentlemen, let us welcome the IGP 115th webinar with the topic Driving Equity and Quality in Education with Technology, with our speakers, Muhammad Samir Nada from Egypt, Dr. Shobik Ganguly from India. Our first speaker is Muhammad Samir Nada. He is a CEO and founder of Glabi School with the topic, The Role of Virtual Lab in Online Education. Let us all welcome Muhammad Samir Nada.
Larisha, can you hear me? Hello.
Hello, sir. Mhm.
You did a simple mistake. Our first speaker is Dr. Shovik Ganguly from India, and Dr.
Oh,
Mohammad Nada sir will be the second one.
okay, sir. I'm sorry for the mistake. I would like to.
No problem, no problem.
Yes, sir. I'm too excited to introduce them both. All right. So, dear audience, sorry for the correction. Our first speaker is Dr. Shobik Ganguly. He is an assistant professor of Tapar Institute of Engineering and Technology Department of Electrical and Instrument Engineering with the topic IoT-based renewable energy technology. Once again, let us give a virtual round of applause for Dr. Shobik Ganguly. Hi,
Thank
sir.
you
Good
so much.
morning.
Hello, am I audible?
Yes, sir. The floor is yours. We're all excited to learn from you.
Okay, fine. So let me first share the PPT first, and then we can start introducing the topic as well as with me. I think this is how we'll go about.
Yes. All right. Once again, Dr. Shobik Ganguly from India.
Is my screen visible too? Kaushik, is my screen visible to you?
There's no slide yet, sir.
Okay. Let me scroll so that you can see it.
There's no yet slide. So we will be patiently waiting for the slide.
It's still not visible.
Yes, we're not yet visible.
It's still not visible,
Okay,
sir.
let me stop sharing and do it once
Yeah.
again.
So share with your entire screen.
Okay. Now,
Alright.
Yeah. Just start from the first and make it presentation mode, sir.
yeah,
Yeah. You can continue, sir.
yeah. So, good evening, participants. Good morning to few of you who are in the Western countries, and uh, good evening to my organizer, Kaushik, and I'm really thankful to be presenting before a live audience, and we'll be having a discussion on the topic of IoT based renewable energy technology. Mostly, I'll focus on the controller realization or IoT based controller realization for PV system. So basically, it is the photovoltaic monitoring system which we'll be talking about, and in the process, we will also get some results. We will showcase some of the results which my PhD scholar, Ms. Jyoti Gupta, has obtained, and we have already published that work in a Springer book chapter. So we will be taking you in the next 40 minutes through the particular topic, and I hope that I'll be also encouraged to answer few of your queries at the end in the question answer session. Before that, let me, although the presenter has already introduced me, let me give you a little bit of about my profile, and so that you get to know me as a person. I am working in the Department of Electrical and Instrumentation Engineering at Thapar Institute of Engineering and Technology, that's in Patiala, in the northern part of India. And I have been serving this particular department for the last 12 years, and it has been a long journey. My educational background: I am a BTech in electrical engineering, MTech in mechatronics, and I did my PhD in the area of system identification and control. So mostly I work in the area of meta heuristics and control systems and system identification, to be very honest, and it's a very small exploration that we have made some inroads with IoT based renewable systems. So this is the part. Apart from that, I have 9 SCI publications which are in good top rated journals. At the same time, I had uh, patented a few international patents, and apart from that, a few of my Indian patents are also published, and they are awaiting grants. We have already submitted the respective review comments, examination comments. So in times to come, those will be granted as well. So this is about me. I have been editing 3 books as of recently. There are 3 books titled as Intelligent Green Technologies for Sustainable Smart Cities. Uh, Another book is there on industrial control theory and applications. And the third book is on linear and nonlinear system modeling. All will be published by Wiley, and I have already published 20 plus book chapters in top reputed publishing houses, and few are under acceptance. I hope that you can scan with my name in Google Scholar, and in the meantime, you can also get an overview about the recent works that are being published by me. So this is basically a work which I had with my PhD scholar. There are other authors as well who has also contributed, and mostly the work has been contributed with the help of the PhD scholar, and she is working under me for the last 1.5 years, and she had successfully published one paper in an SCI journal already, and his second paper is almost due in revision, and she has already been granted with a international patent as well during her work process of her PhD work. So mostly we will start the discussion with today's discussion on the theme of renewable energy sources, which you feel that with the consumption of electricity and some environmental concerns, we are gradually talking about the development, or we are talking about the need for more and more renewable energy sources. So naturally, from the economic point of view, from the reliability aspects, we are preferring the electricity generation from the renewable energy sources. And we will also talk about a little bit of microgrid as well, which is basically your distributed generation resource, constituting these days with photovoltaic systems, with wind as well as digital generators. So now we talk about the implementation of the microgrid in a distribution system, which took place in the early years and gradually being encouraged by different agencies as well as different utilities as well. And with the development of microgrid, which we are focusing on today's lecture, we are also having the development, or it has also increased by leaps and bounds the operation of the power electronic devices in the power system for efficient and effective power quality. So at certain point of time, we'll be touching this particular topic on power quality as well, because some performance measures has to be there with respect to the harmonic content, so that we will also talk about power quality issues in the power system, and that we will showcase some results as well as a scheme. So the microgrid, it is usually installed in near to the substation. Basically, it has got some essential features, and it can be operated in two different modes. One is called the islanded mode, the other is the grid connected mode. As the name implies, islanded, it will be in isolation, and when it is being connected to the grid, this is there that during the time of grid failure or due to the maintenance of the grid system, we can always use the islanded mode of operation. As well as we can have the interconnection of the microgrid. With the increase in the interconnection of the microgrid in the distribution system, it has caused some problems with respect to the voltage fluctuations, sometimes some over voltage, steady state over voltage, and also there is an increase in the system loss as well. Some issues which pertains to the voltage regulation of the different devices and the protection devices as well, and therefore some appropriate allocation of the microgrid is equally desirable. So these are some of the different types of microgrids that we will be taking you through. The DC microgrid, the AC microgrid, or sometimes there is a hybrid microgrid which combines both your AC as well as DC microgrids as well. So talking a little bit about the solar energy systems, because mostly we will be focusing as far as the renewable energy systems are concerned. We'll be focusing mostly on the PV system monitoring system, which will be IoT based, and we'll be talking about the control scheme and how do we frame its controller. So we are into there are two factors on which your solar energy system or your photovoltaic systems are dependent upon. One is the temperature part, the other is the irradiance, as well as We will also focus on the maximum power point, which is normally that particular point where your maximum power output is being delivered by your PV array. So these are some of the common topologies which you would like to introduce in the background of work, so that you get to know that what we are expecting to move out for. Your control scheme, which we have formulated using a neural network. So basically, what is a neural network that we need to know? And it is being designed to provide a gating signal to your inverter circuit. So mostly we are going for the inverter controlling in order to improve its performance. Basically, your artificial intelligence or your ANN comes under artificial intelligence or artificial neural network, which is basically your machine learning approach, and it contains a number of artificial neurons to perform a particular task in a particular system. So mainly we will make use of a comparison of a standard PI controller with that of an artificial neural network, and let us see how we are able to cater to the problem of the total harmonic distortion in the system. And we will also carry out the fast Fourier analysis or Fourier transform analysis, or FFT analysis rather, commonly known as, in order to determine that how much is the total harmonic content of the power across, or if I use a standard PI controller or if I use an artificial neural network controller, what will be the impact on the THD level with respect to your power quality. So we are definitely going to monitor that too, and we will also tell you that there is a IEEE specification for which your total power, in order to achieve power quality in a particular device, the total harmonic content should be less than equal to 5%. So we will also ensure at the end of the design, we will also ensure that the THD level is up to that mark or not. So we are to investigate on the control scheme. Mainly we will be focusing on the inverter control scheme, and this inverter control scheme will be helpful for us to improve the efficiency of the power transfer that takes place between your PV system and the grid. So obviously we have to take a test system which we have considered as an IEEE 13 node test feeder system, which is being considered as a grid system, and it is commonly being used in the literature as well to test the different features of a distribution network operating at 4.16 kilowatt. So this is basically a test system which we'll be introducing as a microgrid system, and we will try to understand the various features and try to notice the different power quality issues with the help of the inverter control scheme. Now, a little bit about the need analysis and why we are focusing on, or why we are emphasizing on, some intelligent control scheme with the addition of the IoT or the Internet of Things. The main problem that usually arises in monitoring your output power of a photovoltaic system is your accuracy of result and the time duration which is being used for the detection of the fault and obtain an appropriate solution to it. So detection of fault or the time duration involved in the detection of the fault should be reduced, and we have to be very accurate in detecting the fault and provide an appropriate solution to it, for which we prefer to make use of the Internet of Things, which is basically an emerging concept, and it has been applied in each and every sphere of your technological developments. So we will be having an IoT based controller realization in the process for a PV monitoring system, and we have already told you that we have taken a microgrid system which we will be telling you in much more detail, and we will also provide the block diagram representation as well. We will try to keep for the general audience less technical as far as possible, so that as a layman you can understand the concepts and try to make use of it and try to follow similar articles, what are the developments that are taking place in the process. So we have as an information sharing where your elements are being attached to your wireless system or a wired network. So basically your IoT based systems are attached to a wireless network. So we are trying to connect between the two, a wired network with a wireless network, and so that some information sharing will take place between the two, so that any corrective action of the control scheme can be taken care of with the help of the IoT based technique. So this concept that we are trying to bring in basically pertains to the field of electronics, because when I'm talking about Internet of Things, obviously some communication may be involved. So mostly the application so far has been restricted with the field of electronics, or in some IoT devices have already been applied in your home appliances as well, some electric cars applications as well, some industrial security purpose. We have a industrial Internet of Things, which is called IIoT, which is also being popular. So although we are not claiming that this is the first time that we have applied IoT in a PV monitoring system, there are other researchers who are making also some inroads with the development of monitoring scheme, with the development of some wind emulators with the help of IoT based practices. So it is for the individuals as well as the companies as well to be getting associated with the solar panels, that your IoT will make it possible to increase the MPPT reliability and as well as its performance. So mostly we will also touch upon this maximum power tracking algorithm as well at certain point of time, and we will try to make up in such a way that we can understand the concepts. So this is the model description which we would like to tell you. So it will consist of, we will brief you each and every module in details, and after that we will showcase some results as well. So basically we are going to touch upon the photovoltaic module, of course. We are going to talk about some DC link capacitors and the inverter circuits as well, some filtering schemes which are there, which will be using our RL filter to reduce the harmonic content. We'll be making use of the transformer as well as the load part, and once you connect it to the grid, we will touch upon the point of common coupling as well as the grid. And finally, of course, our main work which we'll be focusing upon is your controller part. So this is how we'll operate, and we will brief you in the next few slides. We will be brief you about the different modules that we have selected in the microgrid. So this is the test system which I had already told you. It is almost a repetition for you, that we have considered as a grid system, IEEE 13 node system, which is a test filter system. We will have the network also, and it is fed to a distribution network which is operating at some 4.16 kilovolts. So basically we will talk about a few important issues. Try to keep as simple as possible, because there are many technical terms being employed. This photovoltaic module is being simulated with the help of MATLAB Simulink, and it is having a photovoltaic array as well. And how are these arrays constituted? There are 8 series connected modules and 96 parallel connected modules in a particular string, and we have assumed standard test conditions and standard irradiance conditions for your we call it STC condition, standard temperature condition. We call it STC, which is selected considering the Western countries' temperature as well, which is selected usually as 25 degrees Celsius, and 100 or 1000 watt per meter square is the irradiance, which is normally the test case which we consider for our analysis. And we have tried to generate this much amount of power using the sun power so and so model, and it is being selected from the module block available in your PV array. So this is about the module. This is basically the description of the system which we have considered for our analysis. So these are some of the model parameters, because we have already selected certain values based upon which some currents and some diode currents. This is a part of the diode model which we make, which we call it as the shunt resistance and the series resistance part. And usually your saturation current is of the order of 10 to the power minus 11, so that you can find it over here. The maximum power is being given as 444.86 watt, and a number of cells per module is 128, which has been considered for this simulation work. So this is about the model parameters. Moving ahead, for the DC link capacitor and the inverter circuit, usually a three-phase inverter circuit has been connected to the DC link. The DC link capacitors are there to stabilize the DC link voltage of this grid connected inverter. And as because of this temperature and irradiance variation, we have considered the capacitance to be allowed for electronic control, and we also expect that it should maintain the maximum power output. Your three-phase inverter will be converting your DC voltage to an AC output. So this is about your filter. The filter, as I told you earlier, that the filter is mainly being employed to reduce your harmonic distortion, which we expect as per the IEEE standards, which we expect to be less than equal to 5%. So we have examined that condition as well, and we have also kept some overcurrent prevention scheme, and a three-phase coupling transformer is being placed between your microgrid as well as the grid system. And there are three-phase coupling transformers usually connected to star to the delta fashion, and we have been able to step up this voltage from 240 volts to 4160 volts at a supply frequency of 50 hertz. And these are some of the system parameters. If you miss out anything, nothing to worry about, because these things are available in my research article as well. And basically your load, which is usually your distributed load for this IEEE 13 node system, feeder system, which we have used. We'll at certain point of time we'll also talk about this feeder system, and we'll also have the diagrammatic representation of this feeder system as well. Let us discuss about point of common coupling, which is being described with the help of some circuit breakers between your PV system and your grid connected system. And this point of common coupling, it plays a vital role in our proposed method, because it is isolating our PV system from the grid system, that is in the islanded mode at the time of any blackout that may occur in your grid, and when the grid is under maintenance also, so as to supply your necessary power to a particular load in case there is some deficiency in the microgrid. And grid being used already, we have so many times, we had been time and again being discussing that the grid is a standard IEEE 13 node system, which is a test feeder system. This is your representation of the microgrid system, which we have considered is a block diagram representation containing your inverter, your point of common coupling, which we have denoted as PC. We have also denoted your load as well, and the PV system is being fed to the inverter, which is being controlled with the help of a controller, and we will talk about the control scheme, about the inverter control scheme in much more details in the succeeding slides. So talking about the proposed control features, we are gradually moving on into our main focus of our work, and we will be talking about the microgrid system, which we have already told you that it operates either in your islanded mode or isolation mode and the grid connected mode. So we require to have a proper controlling action, which is considered to be an essential feature for steady operation as well as efficient operation in either your islanded mode or in your grid connected mode. So some specific functions, although there are many, some specific functions which you would like to highlight upon, that we need to control the power flow from the grid end to the microgrid end. We need to have a proper synchronization of your microgrid with the grid system. We need to have a proper regulation of load sharing that may take place between the grid system and the microgrid system as well. So these are some of the control functions that we are looking or that we are expecting, due to which we need to develop some logic for achieving these goals. Some more, we need to also regulate your frequency as well as the voltage in both your operating modes, whether it is your microgrid is operating in the grid connected mode or it is operating in the islanded mode. We are also doing some optimization regarding with respect to the operating cost or the operation cost of this microgrid system. And while it is being shifted between two modes, we need to handle the transients and we need to restore your desired conditions as quickly as possible. So it is an utmost necessity for us. So these are some of the controller functions that we thought that we should discuss over here. We will explain shortly about the maximum power point tracking algorithms, and we will also highlight upon what we are actually expecting from it. So maximum power point tracking, this actually extracts your maximum power from your photovoltaic system, which is usually being generated from your photovoltaic cell or your photovoltaic module at a specific environmental condition. We have considered over here the standard test condition and an irradiance level, which is 1000 watt per meter square. So a specific voltage in which your solar device generates this maximum power output is your maximum power point. There are several techniques by virtue of which we can formulate the maximum power point tracking algorithm, of which we have used in our work the Partav and the observe algorithm, which is called P and O algorithm as well in this particular work, in order to determine your maximum power point. And we also take into account a single sensor to detect this maximum power point, which is a voltage sensor, and which reduces your cost as well as the complexity of the system. And this particular technique is quite easy as it has least time complexity. So these are some of the features that we try to put upon. You can have a very wide literature available on maximum power point tracking algorithms, and people have been working very sincerely, very dedicatedly on these maximum power point tracking algorithms as well. Now gradually we are coming to our work, and we are focusing on the inverter controller, which is having a double loop. There are two loops. One is called the outer loop, the other is called the inner loop. Usually your voltage control loop is your outer loop, and the current control loop is your inner loop, which is considered to be the primary loop to keep your active and reactive current signal of the grid. And your outer loop is there to maintain your DC voltage of the PV array. So these are the two things that we are basically controlling with the help of a standard PI controller as well as with the help of an intelligent based controller, which is also IoT enabled. So talking about PI controller for the inverters in a little more detail. So we are to achieve a power factor which should be close to unity, and usually we for efficient grid interconnection, we expect our power factor to be close to unity. The voltage control loop, it will provide the output of this ID current, which is usually the reference of the current, and while keeping your IQ value to a minimum value, usually we keep it to a 0 value, and this is being done with the help of PI controller in order to minimize this particular error. Now your inner loop will provide your voltage output. Inner control loop is your current control loop, which is to regulate your output voltage VD and VQ, and the tracking error can also be reduced, and your tracking speed can also be enhanced by regulating the PI controller in the inner current control loop. Usually we have taken into account a feed forward compensation, which is included in these loops in order to decrease the disadvantages of the perturbation or the deviation that may take place in the voltage of the grid. So apart from that, we have a little bit discussion about the phase lock loop algorithm, which is being applied over here in order to regulate your active and reactive power, which is being injected to this feeder system, 13 node feeder system. And usually, apart from what we are talking or what we are seeing out here in the slides itself, your phase lock loop is to help in locking and synchronizing your frequency as well as its phase angle output of the voltage with respect to some reference current using certain transformations. And its purpose is to provide a very minimum amount of speed regulation as well. So in order to control the speed within a very small range, we usually go in for the phase lock loop algorithm. And the output of your control loop and your voltage loop, it is being fed to the converter block, whose function will be now to sense your voltage values and the current values and convert these values in the DQ reference frame as the DC quantities. So basically this is the work being done with the help of the DQ transformation. Apart from that, the output of the converter will be fed to over-modulation in order to increase your linear region of operation, and output is transferred through your pulse width modulation technique or PWM 3-level pulse generators. We cannot emphasize or cannot provide you with each and every technical details. I hope that you can go through our work, which is already reported, which is already published, and you can go through that work and get the details of the different PWM techniques that are being applied. A little bit of focus we'll like to make about the artificial neural network, which is usually massively parallelly distributed processor consisting of some processing units, and it has got some fundamental property of storing some knowledge of experiments and make it available for us. And there are two aspects which it resembles with your original system of your brain. That is the strength of the interneuron connection, which we call as the synaptic weights, which are used to store the knowledge which is being gained. And your network, it also gains some knowledge from its environment through some learning process. So we have used Levenberg Marquardt algorithm, and which is used for training your neural network, and it is usually a second order optimization. This algorithm is itself a separate lecture, so we will not go into too much of details, but this algorithm, which will of course we can say that it takes lesser computation time, it is robust, for which it is being preferred over the conventional algorithms like Gauss-Newton algorithm or the gradient-based approaches that are available in the literature. Little bit about showcasing our work regarding the flowchart being developed This is the ANN based controller whose flowchart has been developed. You can see over here that we have considered the mean square error, which has been optimized, and these are the basic steps of the ANN algorithm. Basically, main focus will be to minimize the error, which we have considered as a mean square error, although there are several types of errors like root mean square error or sum of square errors, which can also be taken into account in the process. Regarding the monitoring system, gradually we are moving on into our main work, that is the MPPT design, which takes into account two parameters which we have focused upon. One is the perturbation period, which is being denoted over here by TP, and the perturbation magnitude, which is denoted as X. And these two are having a greater acceptability in the literature, so for which we have preferred to use these constraints. We will skip this because this will be slightly mathematical if we go regarding the discussion of these constraints. So we will just simply show you that this TP will be greater than equal to. We will tell what are the terms all about. Omega n is denoting your natural frequency of this inverter system. Delta is denoting your damping factor for the system, and epsilon is denoting the controller variable of the system. Mainly, it is having an assigned value of 0.1, which we have considered. Another constraint which we have considered, we have defined those terms. I think Koshi can share after this, and of course the video can also be recorded. You can go through each and every term and know the details about each and every term. So these are also the constraints which we have applied in the monitoring system of the photovoltaic type system. So this is basically the schematic representation of the IoT based systems which we are talking about. So it involves some readings from the sensors, it involves some use of algorithms, some switches, some API calls are there, of course, and in the process we can monitor your photovoltaic system as well. Some of the results I think I am almost done with. Preferably, I'd like to showcase upon the power quality results. So I'll skip this particular slide, and we will mainly include the power output, the voltage deviation, and focus on the total harmonic distortion, as well as we will showcase the results for the phase angle deviation as well. So nothing to worry about if you are not understanding these facts and figures. These facts and figures are generated from the results that we have simulated, and we have organized it in such a way that we can get a comparison between the parts. Some of the power quality issues which we have, these are also some of the technical details regarding that how much time is being made by your PV system and the grid, when the grid will be operated in grid connected mode and when it will be operated in the islanded mode. So based upon what we got some power output variations across the load when it is being connected across the load, and we have also made a comparison between the standard PI algorithm and the artificial neural network controller that we have proposed in this particular work. Apart from that, we have made a voltage deviation analysis across the different buses, the different 13 bus system that we have considered, a 13 node system which we have considered, for which we have also observed some voltage deviation occurring at the different buses. This I was emphasizing on. This is the first Fourier transform analysis which we have showcased out here for a standard PI controller, as well as we have also focused it on for the ANN based controller as well. So you can carefully observe that what we have told earlier, or what we have claimed earlier, that our THD level should lie below 5%. This has been achieved. You may see the total harmonic distortion level is about 3.11%, which is of course less than your 5%. So we have been able to successfully fit in the power quality with respect to the harmonic content reduction with the help of RL filter, as well as with the help of the PI controller, as well as the ANN based controller. Here, over here, you will find that the THD level of the ANN based controller is even less than that of the standard PID controller, or the conventional PID controller which we have used. So these are some of the phase angle representation using your standard PI controller and using your ANN based controller as well. So these are some of the results. Some important conclusions that we would like to highlight upon, that the interconnection of the photovoltaic system as a microgrid will definitely increase the reliability of the power supply as well as the power quality by regulating it with the help of the IoT based inverter controller scheme. So the IoT based ANN inverter control scheme which we have applied, this is effective. This is having some reliable power transfer that takes place between the grid system and the microgrid system in order to satisfy your desired load, which is being demonstrated in this particular research article. As well as we have talked about that the ANN based controller, which we have seen already, that it is being compared with the IoT based PI controller or the standard PI controller, and it justifies its technical feasibility as well. So this is all from my side, and this is the publication which we have, you can refer. This is for your suggested reading regarding the paper, and you can get to any queries, any explanations regarding the paper, you can get me because I am also the corresponding author of this particular paper, so you can get my email ID being tagged with the paper, and it is, I think, available in ResearchGate as well as Google Scholar, so you can refer to this particular article. You can also refer to some of our articles like IoT based wind emulator system which we have already incorporated, and there is a smart monitoring system or smart remote monitoring system which we have developed with the help of the IoT concept. So this is all from my side. I think over to the organizers.
Once again, thank you, Dr. Shobik Ganguly, for a very relevant topic. The topic that you shared for us really works a lot, especially we're in this new normal, and this is education's new normal. It's really challenging, but because of what insight you have shared, it provides opportunities for all students, and of course, all the educational setting will be more safer in learning environment because of this IoT. Right, so to all our audience, you can ask questions later. Just type your questions in the comments section below. And Dr. Shovik, of course, will share more answers about it later. Once again, a virtual round of applause for Dr. Shovik Ganguly.
Thank you, ma'am.
And now we will proceed with our next speaker, Dr. Muhammad. Sorry, though supposed to be, he's our second speaker, but a while ago I'm too excited to introduce all of the speakers. So our second speaker is Mohammed Samir Nada. He is a CEO and founder of Vlavi School. And the topic that he will share with us is the role of virtual lab in online education. Let us all welcome Mohammed Samir Nada.
Thank you so much. Welcome to you.
Hi, sir. We're finally meeting you because a while ago I'm too excited to say all your names.
Yeah, thank you so much. Yes.
Thank you, sir. Without further ado, we will now be listening to the things that you will share with us.
Okay, thank you so much for all participants and all organizers. It is my pleasure to participate in this great international event. And also, I'm very happy to share with you some point about how to provide interactive and practical e-learning anytime, anywhere to our students. At first, I'm so happy to introduce myself to you. I am Mohammed Samir Nada, founder and the CEO of VLABI platform, and I have a master in education technology and a PhD researcher in education technology at Damietta University, and also I am computer lecturer in some computer and business administration institute in Damietta. Also, I am winner of the Alexo Prize for Arab mobile applications, and I was selected among the best education innovators in Africa by African Union and also United Nations office in Vienna. Now let us discuss about what about the content in our e-learning platforms. We have three types of student interactions in e-learning platform. The first interaction is between student and content. It is the most important form of interaction in e-learning. So once a student to access learning materials such as multimedia or lectures or video or interactive simulation program, they should be able to use it their on a way. So they should be able to start and pause and repeat and forward the parts of the course to master it. The second type between student and the interaction between student and teacher. This type of interactions happen when teacher delivers information about their student or provide feedback to his student. It also happens when student ask teachers some question or communicate with him about the course. And also the third type is interaction between students or student with another student. This type interaction happen between two students or among a group of students studying the same course. This can happen with or without the teacher. So today I will discuss with you the opportunity of student interaction with e-content or content in e-learning platforms. We have as four forms of content in e-learning platforms. The first type, all just content include text and image through normal website or PDF files. This type doesn't allow students to interact with the content. And the second type of content is infographic or video. It is include a good visual side as animations and motion graphic. This type is able to communicate information better, but there are still a few opportunity for interaction. The third type, through video platforms, the student can control his learning by stopping and restarting the video, but that doesn't not enable the student to interact fully and actively with content. Finally, the interactive simulation program. It is programs that enables the student. Yes. Finally, is the interactive simulation program. It is programs that enable the student to pass through the same real experience, but through virtual environment. Here, the student role is very important and active during learning, and also be fully controlled in his learning, such as virtual labs and games, educational games, such as VLAB platform. As we know, the science experiment is the most important activity that was affected by closed schools due to COVID-19, and it is very difficult to conduct most experiment at home. Due to COVID-19, we have many problems in traditional laboratory in most schools in world, such as crowded labs and closed schools depend in theoretical teaching in a lot of our online platform, and also some dangerous experiment. There are a very dangerous experiment in our curriculum, and also lack of chemicals and lack of time and high cost of labs set up in a lot of schools. So we create the first virtual labs platform for school students in MENA to allow them to conduct the science experiment in an online environment that simulates the traditional laboratory and has all lab equipment and the chemicals and customized for each student according to his curriculum. So we provide them unlimited science experiment anytime and anywhere without any danger, and we try to solve many problems in our traditional laboratory. With very easy, student can enter VLAB platform and choose the experiment that he need to conduct and open the virtual labs. Student can select all tools from library from labs tools and conduct all steps of this experiment in virtual table. And also there are Blackboard include a mini interactive activity for about this experiment, and also a lot of theoretical framework about this experiment. So student can do all experiment without any danger, with any time in anywhere, and also science teacher can explain all experiment in our platform without any cost. Just include log in a VLAB platform. This video show some experiment in our platform in a lot of fields, chemistry and physics and biology. We try to cover all experiment in all fields in science, such as chemistry and physics and geology, and also cover all levels of pre-university education to help all students to conduct their experiment. Also, our platform now is available in 5 languages: English and Arabic and French and Indonesian language, and also German. Yes, a VLAB platform helps students to conduct experiment anytime, anywhere during COVID-19 and also after COVID-19 and before COVID-19. VLAB platform help solve problem in our traditional science laboratory, such as lack of time, lack of lack of equipment and tools, and also protecting our student from danger of some experiment in our curriculum. And also we help science teacher to explain the experiment in practical way in online platform. But we have some new addition value to be ready for a new study year with the best technology available in education. The first value is use the gamification in virtual labs. So we will be first gamified virtual labs in MENA or in World. By that we mean use of tools and the concept of games in education, so that the student feels all the time that he in games, not in serious learning. With this, we add many features to VLAB platform, such as motivating a student to continue learning and encourage the concept of competition among students, and help a teacher to evaluate his student, and also help student to think about problem solving. Also, this screen show our dashboard for student. Student can follow his progress bar, and also schools and the science teacher can see this progress for each student. The second addition value it to provide sign language in all experiment to display instructions for student with disability hearing, because it is necessary to take into account the needs of methods of all our students according to SDGs of United Nations. During our journey to create the VLAB platform, we participated in many international competition, and also we selection selection by United Nations and African Union as a top innovating education in the world. We also won in some local and international competitions, such as Adventures and Islamic Development Bank competitions. Finally, we are chosen by African Union to participate in Innovating Education in Africa last year. Also from United Nations to participate in Zero Project conference in United Nations office in Vienna. Now I would like to take you in a quick navigation to conduct an experiment through VLAB platform. This is our platform. Just log in vlabi.com. Our platform is available in 5 languages: English and Arabic, French, German, Indonesian. And then this homepage for our platform, you can go direct to labs, and by this filter, you can select the curriculum and then select the level and first and grade and the semester. From here, we can select third grade in Egypt, and then select second term, and select science to get all list of experiment in this semester. Yes. Here, just you can choose any experiment from your list of this experiment, such as I will select this experiment. In a few seconds, you will get fly virtual labs in your device, um, such as the laptop or tablets or mobile phone, any smart device. Here you can enter to full screen mode. I will turn off my cam. Yes. Yeah, the first you can select your language from Arabic or English language. We will select language, and also you can choose your mode with instructions or no instructions from here, and then you also you can control in the background color from here. I will select this color. You can okay. From here, you can select all tools about this experiment according to this white box. After select your tools of this experiment, also you can go to Blackboard to see all theoretical framework about this experiment, such as tools of this experiment and the steps of the experiment and the conclusion about this experiment, and also activity and tests. Now you can conduct or steps about this experiment in virtual table. Our science teacher can explain all experiment to their student with very easy in our platform. Uh, this is a just example about our platform. and you can try a lot of experiment in our platform. Just log in VLABI, and there and here you can see all social media, um, our social media channel, and also you can add any comment here about any experiment. Also, you can navigation about our curriculum without with this page experiment groups. You can select all experiment about physics experiment and chemistry or chemistry experiment. Finally, I'm very happy to be here with you, and I hope to solve to our platform solve some problems in traditional laboratory enrolled. Thank you so much for your time, and you can visit our platform to enjoy with science experiment. Thank you so much for organizing.
Once again, thank you, Sir Mohammed Samir Nada. I'm really happy, sir, with all the ideas. I'm hoping that I can experience virtual labs too. Maybe after this webinar, I will immediately go to www.blabby.com so I can try the virtual lab. So this virtual lab, sir, am I correct? You can have multiple series of experiments so you can get the results of the experiment. So you can try it, sir. I mean, there's no limit, right?
Yeah, now we try to cover a lot of curriculums in most country, and also the science experiment is very general with a lot of curriculum. Um, we have a lot of experiment in our curriculum. It is needed in your curriculum, such or a lot of Arabian country. It have is the same experiment. So we cover general science concept about our platform.
Wow, that was really extremely captivating. I'm really interested when it comes to science too. Thank you so much, sir, for being an eye opener about virtual labs when it comes to education.
Okay.
So even
Okay.
though we're
Thank you
not
so much for your time.
expecting, it's nice to have an additional knowledge about this virtual lab. So it's not only for the medical field, but in other disciplines like chemistry, biology. So this virtual labs really helps the education's new normal right now. Once again, thank you so much, sir. We are really happy that you're with us this evening.
Thank you so much. Nice to meet you. Thank you.
And now to all our lovely audience, it's time for quiz competition. So I guess everyone is ready to take the quiz competition. So we're really hoping that we will see you in the upcoming webinars of IGP. So Rachel Trinidad is here with a quiz. Thank you for joining. Karen, Troy, Lloyda Diaz, Chris, a lot of names on the screen. Thank you so much for participating. For those who are not yet joining, please join at slido.com and the code is already shared on the screen. So we can claim the e-certificate later after this session by clicking the www.eduigp.com and you can claim your certificate for tonight's session. And for all your questions later, it will be entertained for the time for question and answer portion later after the quiz. So you can type your question. And we're ready. Good luck, everyone. 987644321. In education, so what will be your answer? Oh, men and women should have equal learning opportunities. Yes, I agree. Now, next question. Which of the following are positive uses of technology in health education? Choose wisely, everyone. The correct answer is A and B. Congratulations for the one who got the correct answer. So, what do you mean by quality education? So, I think quality education, what will be the answer? Wow, 75% got it correct. Quality education is good for improving health, reducing poverty, or both. Congratulations. Next question. What do you mean by education? So education will help you get a job and improve your life. That's correct. Congratulations for the one who get the correct answer. So for the question, what is assistive technology in the classroom? Can everyone know the answer? Wow, 50% got it correct. So it's improve or maintain capabilities. Congratulations. Now let's proceed with the next question. Yes, of course, it should be developed country, so it has quality education and it has access to technology. I think Anaba is on the leaderboard. Congratulations. What percentage of researchers in science and technology are women? What percentage? Wow, 30% of women are into research. That's nice. I think we have 8/10. So we have two remaining questions. You think it's very easy to know the answer. Of course, the quality education needs clean schools, teachers, and books. This is the last question. Yes, assistive technology, maybe low tech, no tech, or all of the above. Congratulations, Roselle. You are the cream of the top for today. So, congratulations to all the first, second, and third placers of IGP quiz competition. All of you will have certificates. Congratulations, Jezan Ahmed, our Anthony G. Salvacion, and of course to our first placer, Roselle Gaviria. Congratulations to all of you. And for those who finished the quiz competition, congratulations too. Thank you so much to all who participated. We will now proceed with a question and answer. Once again, good evening to everyone. Now,
Good
all of
evening,
your
ma'am.
questions will be entertained. Just type your question in the comment section below and we will read your question. Once again, we are really acknowledging the two speakers for tonight, Dr. Shobit Ganguly and Mohammed Salim. It's really our pleasure that as we with this very topic that we will be sharing with you. So if you have any questions, just address the speaker's name and we can read your question. Once again, just type your question in the comment section below. And don't forget to address the speaker's name. So we have the comment. For the first question for Dr. Ganguly, Can renewable energy sources mitigate climate change? If yes, how do renewable resources hold up in a warming world? And that was a nice question.
Yeah, definitely. My answer will be yes. Renewable energy definitely will mitigate climate change. But the thing is that uh, we are having so many renewable sources. Of course, wind and solar energy are the successful, and definitely we need to have or optimize the use of these renewable energy sources. Along with, we are gradually moving on for more of the renewable share, rather than on the conventional sources of energies like your thermal power plant, your nuclear power plant. So these resources have definitely, if they are having less usage, definitely we are expecting that it has less carbon dioxide emissions. Definitely, it will have impact on the climate.
Thank you so much, sir. The topic that Dr. Ganguly shared to us really helps us leverage renewable energy and make it more efficient. For the next question, to this pandemic and to the new normal system of education, do you think adjustment to the quality education is visible when the teacher is not really sure if student is willing to learn? So I guess that's for Muhammad. Question came from Kurt.
Yes, this question for me.
Yes.
Yes. Okay. Uh,
I will repeat, sir, the
yes,
question.
yes, yes. We must to enhance skills of our teachers, such as our science teachers, to enable to use our education technology and learn this technology to to their student. We very important to enhance and improve the skills, the technology of our teachers to can conduct this experiment to in front of their student, and then teachers learn student how can use this technology. So uh, we always think is the teachers is very important members in this cycle. So we can improve. Uh, we can deliver all information to the teachers, and then teachers learn student the skills of use education technology and uh, learn anything after that. Okay.
Thank you so much, sir. For Dr. Ganguly, how can we define e-learning? What components are to be included in e-learning?
Uh, well, we have already shifted to the e-learning mode on the various occasions, be it in the form of webinars, be it in the form of uh, some classes pertaining to online education, some workshops. We are already conducting our conferences in virtual mode. So these are the different types of e-learning components that we have. But the main obstacle that we have faced, those who are particularly teaching in the technical courses, they are say, like Professor Nadasar has already mentioned about the virtual labs. So definitely this could be of the maximum scenario, because in technical education we don't expect virtual labs, and we had some online platforms from the different institutions of repute who are already into the development of virtual labs. And I think IIT Kanpur and another IT, I cannot recall, I think IIT Mumbai, they are already into the process of establishing every sort of activity pertaining to the different experiments and different circuits, different systems. And they are already, just like Professor Nada has already mentioned in his talk, and he showed with the help of a very lively animation showing the use of virtual labs in the science-based experiments. So we have been in the prevailing system, or in the prevailing situation, for the last 2 semesters at least, if I can recall. And both of these 2 semesters I have dealt personally with the first semester courses. So definitely it was a great challenge on my part to execute the lab, or execute the hardware based lab through online mode. And you have to always engage your students uh, in the online mode of teaching, and you have to always put them into some sort of activities, so that they do not feel bored. And there is always a chance of lack of connectivity with respect to internet connection, or the lack of connectivity with your teacher. This happens quite often. So you have to make yourself glued with a teacher, or with the student, so that the effective use of the online teaching or the e-learning mainly will focus upon. So I think these are the components that all of us has tried, teaching through assignments, teaching through some activities, engaging the students in different aspects, and of course the virtual labs, or rather the realistic labs being shown to them through some cameras, or so that they can understand the experiment, they can get a feel of the experiment, and at the same time they can practice it through some simulation work to get their knowledge finally completed. So this is from my side. I think Professor Nada sir can also improvise upon this question, because already the question is there that the virtual laboratories definitely will be part and parcel of our life in technical education. Okay, that's
Thank
all
you.
from my side.
Thank you, sir. It's very helpful, especially here in the Philippines. We're also conducting online classes, and you told us to be more engaging, more interactive, give them more activities. I think it's very effective, especially we don't really see them personally. Now, for Mr. Mohammed Nada, after the pandemic, will the usage of virtual laboratories can still be beneficial?
Yes, I think it will be very useful, very beneficial because we at the before the pandemic of COVID-19, we create our platform to solve many problems in traditional laboratory in most school in Arab country and a lot of country in around world, such as there are very dangerous experiment and very expensive equipment and expensive tools, and also lack of time to conduct the experiment in the class time in traditional laboratory, and also overcrowding laboratory with student. It is prevent the student to conduct all experiment at one in the time of the class. We think is VLAB or any virtual labs platform. It is very important in COVID-19 and after COVID-19. Um, because we still have a lot of problems in all the traditional laboratory.
Interesting. I guess blended learning can work a lot. Now, from Manolita for Sir Nat, students using virtual simulations could be reinforcing incorrect views or biased statements based on experiment experience rather than expertise which will replicate and reproduce. When this happens, how hard does it become for one to find the right information?
Yes, we always say the real experiment it is very good, and the real experiment it is most um, they can provide a student a lot of information about this experiment, but in case we haven't any traditional laboratory, and we have a lot of the problems in our traditional laboratory, we we become we will need any virtual labs to learn our student how to conduct this experiment, and what about the information about this experiment in practical way, not only in our blackboard, um, and not only theoretical framework about this experiment. We always need to do a practical way to learn our student about all information about this experiment. So uh, we uh, we believe the real experiment is very important, but in case we can't do the real experiment, you must do our experiment in virtual tools such as virtual labs or interactive simulation games that simulate traditional laboratory.
Thank you
Okay.
so much. Now for Sir Samir, Sir Nada again. Is Lobby an app or a site?
Yes, Vilabi now it just a website www.vilabi.com. But we try to create our mobile app at the next month. But now it is a website. Also, we have a lot of free experiment in our platform, but all experiment with subscriptions around $2 or $3 to conduct all experiment at once.
Thank you so much, Professor Mohammed Samir Nada and Dr. Shobi Young.
Thank you so much for all
Thank you,
participants.
ma'am. Thank you so much.
Thank you for all the valuable insights you shared. It's really helpful, especially we're still in this education's new normal. So the Vlabi Appster we will be waiting. It's already in place. And Dr. Shobik, thank you so much for all the efficient knowledge you shared. So for today's program name, just click the type the topic. It's driving equity and quality in education with technology. So this the certification link. Just proceed with the www.eduigp.com and then just claim your certificate. Certification class code is not required, and you can the certificate link now is available in the comment and it's already pinned, so you can just click. And if you're not able to click this link, please browse peopleeduigp.com for your certificate. It's very easy to access your certificate for tonight's session. So please don't forget to check in IGP page while celebrating. Celebrate with your e-certificate tonight and check in with IGP. We still have upcoming webinars, so you can just search all the webinars in page. So once again, for the certification, browse peopleedu.igp.com with the title of tonight's session, Driving Equity and Quality in Education with Technology. If you did not enroll yet, you can enroll now and please claim your certificate. Don't worry, certification code is not required. You can also verify your own certificate. So this is the sample certificate of participation brought to you by Institute of Global Professionals. We are inviting everyone to all the upcoming webinars. Save the date on June 20, 2021 for articles writing and publishing. This is a free international webinar, so free learning is already accessible. Just join and then participate. And you can also celebrate, of course, because e-certificate is always provided. And we have the next webinar too. Save the date on June 22, 2021 with the topic Teaching English as a Foreign and Second Language. Brought to you by Institute of Global Professionals. And we have the next webinar, June 24, with the topic Effective Teaching Strategies. We have June 20, 22, and June 24. And we have July 6 with the topic Building Bridges to the New Normal. I guess all the topic is really relevant and useful. And on July 10th, save the date with the topic Applied Research and Action Research. Next webinar, July 14th, with the topic Failure is the Biggest Teacher. Wow, it's a very interesting. And July 16th, transition to new normal from classroom to class home. Wow, I love the title, class home. Yes, really, we're in a class home. And on July 18th, 2021, topic Modern PLC Classroom. And July 22, Educators Leadership Skills. So save all the dates for the month of July. And July 24, with the topic Scientific Research, Writing, and Reviewing. And July 26, with the topic Magic of Logic. Well, it rhymes. I'm excited with this topic, Magic of Logic. And on July 28, well, I love this also mathematics series, special topics in general mathematics. And August 7, trending optimism and research-based practices in education. We have the August webinar series 2. Save the date on August. Rock Google Institute of Global Professionals. And on September 7, we have the ICT uses in everywhere. Yes, we are really into ICT right now because of e-learning. So again, this is the international webinar certificate you can get. So we have a lot of reasons to stay with IGP because IGP provides all this free international webinar where you can have your learning takeaways every time you attend. And don't forget, for those who completed their quiz, please wait for your quiz completion certificates. And for those who stay with us with all the sessions, certificate of lifetime membership is here. And of course, the global membership is don't forget to check in IGP, recommend, and then mention your friends and share this knowledge to all your community. Keep tuning in with IGP, Institute of Global Professionals. All the announcements are in the page of IGP, and you're free to ask questions too. Save all the dates with IGP, Institute of Global Professionals. So see you all on our next webinar, June 20, 2021, with the topic articles writing and publication. Celebrate with all your certificates and don't forget to check in IGP while celebrating. Once again, this is Institute of Global Professionals. And that concludes this tonight's session. To all our knowledge seekers, thank you all for joining us. Please leave a review, check in, and recommend on our page, and spread the information to your friends and community. Don't forget to collect your e-certificate from our website mentioned below. Once again, your participation gives us a reason to provide more helpful webinars that helps us adjust in this education's new normal. We hope to see you all again in the upcoming webinars of IGP. Remember that even in these times of pandemic, learning should never stop. Let us all be optimistic no matter what. I am your host, Lursha L. Pelaez from New Era University, Quezon City, Philippines. Signing out. Stay safe, everyone. Goodbye.